Okay, so let's have a look at our next lesson. So, where did we get up to last time? Last time we were talking about resultant force and some key ideas. In this lesson, we're talking about forces as vectors. Okay, so we're going to be using I and J, and I means something to the right, J means directly up. You can also talk about minus I and minus J too. Okay, um, and we can write things with i's and j's. So 3i plus 2j means 3 to the right and 2 up. So that would look like that. But we can also write this as a column vector as well. So you could also have written that as 3, 2. In fact, I tend to use these more because I find them more useful, and equations and things, they just sort of just jump out a bit more if it's written that way. Okay. Next, we have a key term, and you're going to see this word an awful lot: equilibrium. Equilibrium means forces are balanced. So, for example, making the link to the previous section, if I had, well, let's use our new notation. If I had 3 newtons of force to the left, and I had 3 newtons of force to the right, the forces would be balanced. So we would say this is an equilibrium. Remember, this does not mean that the thing is still, that it is stationary. It can be moving. It simply means that it's going to continue with the velocity that it had before. Okay, so it has the same velocity as before, which might be 0. In fact, it normally is 0, but it doesn't have to be 0. And that distinction is important. Okay, so we have some different forces. This is a force, another, and sort of a mystery force acting on an object. And this object is in equilibrium. In other words, the forces are balanced. So we talked about the word resultant, the overall. Here we would want to find the resultant force, the overall impact of the i's and the j's. So we want to draw a quick diagram. Certainly at this stage here, we want to draw a quick diagram. Later on with the i's and j's, you might be able to move past that. We want to form an equation that's set equal to 0. So we want the resultant, the overall, to be 0. That's what will happen in equilibrium. Okay. And we talked about the I and the J, horizontal and vertical motion, and vectors in general are separate. So we need to solve them separately. If we do all of that, we should be able to work out the unknowns. So this is one way that you could draw the forces on the diagram. In fact, I personally wouldn't do this. I would draw this in this way. So I would draw this as xi plus yj. I always draw like the pointed end of the arrow pointing away. It's just my preference, and you'll normally see diagrams that way, and so on. Anyway, I would do that with that diagram, and what we would say is if it's in equilibrium, overall, all of the I parts must add up to 0. Okay, we'll also do the same with the other part. It's a bit like collecting like terms. All of the j parts must add up to 0. And you can see here, this is sort of one way of writing it. So all of the I parts, all of the j parts. Again, I personally don't like this notation so much. You'll see me use column vectors later. But if you use these approaches, you should be able to find your unknowns this way. How would I do it? So I would write this as 2, 3 plus, so there's our 2, 3 plus 4 minus 1. Minus j, there's a 1 in front of it, so minus 1. Let's do this one at the end. Minus 3, 2, and then plus x, y equals 0. And then I would sort of do the top line here. Okay, so I would say 2 plus 4 plus minus 3 is minus 3 plus x equals 0. And then I'd make another equation with the bottom line as well, which would be 3 minus 1 plus 2 plus y equals 0. Okay, that's how I would do that one. So we can find the resultant of 2 or more forces. In fact, loads of forces we could have. We need to find the resultant, so we need to add them together. So here's another quick example. So there's a force, there's another force, there's another force. So this tells you their direction. So this is 2 to the right, 1 up. This is 3 to the right, 2 down. This is 1 to the left and 4 up. Okay, so find the resultant, in other words, add them up, what's happening overall, and write it like this. Well, again, here they've done the similar sort of diagram, so we could do the same thing. Look at the I's together, look at the J's together. Don't forget the sign in front of the J. Okay, and you'll get your answer here. Part B, are we doing your part B? Let's have a quick look. Yes. So work out the magnitude and bearing of the resultant force. So if you've done vectors already in pure, the magnitude, yeah, this is one to make sure you know every time. Magnitude means we're doing Pythagoras. Okay. So for example, if you had 2i plus j, notice the way I draw this and I point the arrow and stuff. You should be doing this as well. If you do this, you won't get questions wrong with vectors if you do this kind of stuff. The magnitude is they want to know the hypotenuse. Okay, so it's about, square and add to the other part squared, and then don't forget to actually root it at the end. Bearing, well, bearing, if you do the same thing and you point your arrow like that, it's much easier to find out what you need. Bearing, we always draw a north line. So what's the angle between my two arrows? If you draw the arrowhead, you won't get confused with that, and you'll know it's this one here. So what you will effectively do is you'll do a bit of SOHCAHTOA probably inside the triangle, and then 90 minus that. Okay, there are other ways you can do it, but that's the way that you normally see. So 4i plus 3j, that's what the resultant was. That's why it says R, it was the resultant here. So we're finding that one. You might recognize 3, 4, 5. This is a Pythagorean triple. This is a 3, 4, 5 triangle. Okay, bearing, let's have a quick look. So if you draw the north line on, make sure you've got the arrows pointing. It's so much easier to see what you can do, see what you have to do if you do it this way. So opposite over adjacent, that's tan. Okay, 90 minus. Just a final note, bearings are actually 3 digits, aren't they? So when you do all of this, you want it written like that, not like that, like that. Okay, accuracy is important. You've always got to answer the question in front of you at A level. Yeah, there are certain corners that cannot be cut. Okay, so that kind of brings us to the end of that, sort of talking about resultant, and it's a really common exam question. Find the resultant force, part 1. What's the magnitude and bearing, part 2. Great place to pick up marks. You should be getting all the marks every time for a question like this. No excuses, because arguably it's Pythagoras and SOHCAHTOA. Okay, so you've got to be getting the marks for this one here. How many more we got? Let's just have a quick look. Okay, so let's just finish off by talking about slightly more difficult situation. So we've got R is this plus this. Okay, so it sounds like the resultant force is this force over here plus this force over here. Okay. Well, why don't we just do that now? So 4 plus, oh, it's kind of done for us already. Okay, so 4 plus P is the I part. I'm going to write it as a column vector. And, you might see why in just a second. Given that, oh, and sorry, and 3 plus 4P. Okay, so unknowns in this, sometimes there are unknowns in vectors. Given that R is this thing here. Given that R is parallel to I. Parallel to I, well, what does that mean? This is the same I as in I and J. This is that one there. So this thing here, I don't really know what it looks like, but I do know that it's parallel to I. So what does that mean then? Because the top part is about the horizontal, the X, if you like, and the bottom part is about the Y. It's about how much you move, because vectors are about how much you move, aren't they? They're not about where things are, they're about moving to places. So how much do you move up or down? How much do you move in the Y direction if you're parallel to X, if you're flat? Well, you don't move at all, do you? So this bottom part here has to be equal to 0. Because if it's parallel, there's going to be, okay, there can be horizontal movement, but there can't be any vertical movement. If there were, pretend it looked like that, then it wouldn't be parallel anymore, would it? So we're going to solve, oh, there we go. We're going to solve this one here. So 3 plus 4p equals 0 takes us to this value here. Okay. What would an exam question do next? Well, when you know this one, you actually know what this is, and then maybe we do bearings, Pythagoras with magnitude, something like that. Okay, quick question on the board for you to have a go at. So try and put these things into practice. And I would say my advice is to turn things into column vectors. So have a quick go at this one here, read carefully, be very careful when you get to part B, think about what's the same and what's different, and we'll talk about this in just a second. So pause the video here and have a go. Okay, so I'm assuming that you've done that one now. Let's have a look at some of the answers. So you were forming equations in the same sort of way, and you're able to find both P and Q. Let's just quickly look at that. So known, known, unknown. So yeah, 12 plus P, known, known, unknown. Okay, and the reason you're able to do that is because you were told that it was an equilibrium. So the whole thing added up to 0 for both the I and the J direction. Force F3 is now removed. Right. If it's removed, get rid of it. Okay, and start again. The resultant of F1 and F2 is R. Okay, so in other words, 12 and minus 3 is going to be R. 12 minus 3. Find the magnitude. Okay, so again, this is a familiar question to us. 12 minus 3 method, and then an answer for finding the magnitude. Okay. Finally, the angle to the nearest degree that the direction of R, so you draw this one, so 12 minus 3, it looks something like that. What direction does it make with J? Well, what is J? It's the same J as in this one. So you draw that one there. What direction does it make? We're looking for this angle here because that's J. J means vertically upwards. Okay, so you can see, you can find this one out here, opposite, adjacent, in other words, you use tan, and you add on your 90. Okay, this wasn't a bearing, this was just the direction with J this time around. Okay, another quick question here. This one, it's got that part in there. So again, pause the video and have a go at this one. Okay, so I'm going to assume that you've done that now. Just one thing to note, I haven't done this question here, but where P is a positive constant, implies to me that maybe there might be two answers or quadratics might happen and things like that. So it's just something for us to be aware of. Let's look through the answers and see if we can work out what's going on. So find the angle between F2, not the resultant here, just F2 and J. Well, you might have just not done it because you might say, I don't know any numbers, I can't do it, which is nonsense, okay? If you start drawing a diagram, things will come to mind. So P is a positive number, so it's going to the right. Aha, that's why it was there. So it tells you that it goes to the right by P. 2p, well, p is positive, so it's going up by 2p. And you might say, okay, yeah, I know that. I still can't answer the question. Yes, you can. You need to keep going. If you know the method, don't give up. Be resilient with it. So what is the angle made between, let's make it a little bit more obvious, shall we? What's the angle made between this vector here and J? It's a bit like a bearing. Well, if you find this one in the middle, if you find this one here, that's going to be tan, isn't it? Tan equals opposite, okay, over adjacent. Well, hang on a second. Tan theta equals 2. So if you didn't do that question there, okay, yeah, you need to start drawing diagrams. It's not an optional thing. The reason why teachers do it is because it helps you solve problems, okay? We do this one, find that, take it away from 90 will be our answer. Okay, let's just take a quick look at that one. So 26.6 between F2 and J. Okay. The resultant of F1 and F2 is R. Given that R is parallel, so resultant means add them together. So that's a 1 minus 3. So I'm going to say add the I's, you will get 1 plus P. Add the J's, you will get minus 3 plus 2P, or 2P minus 3 if you prefer. So this is R. That's the resultant. It's parallel to I. What did we say about that last time? It means that the J part must be equal to 0. Solve from there. 3/2. Okay, and that takes you to the end of attempt B to have a go at and really try and put into practice what I was saying. So some things I would recommend. Doing this for your vectors so you know what they look like roughly and you can sense check your answer. Vectors with an arrow pointing away will help you get the right answer for directions. Magnitudes, okay, what does a magnitude mean? That's the hypotenuse. And a bearing, remember, bearing is 3 digits only.